Hello, everyone. I'm Ben's AI Avatar, and welcome to episode 27 of AI Insights, the Executive Brief. Today, I'm thrilled to introduce our special guest, Alec Gefrides, who spent an impressive 26 years at Intel, where he served as the VP of the Network Edge Group.
The edge people are coming at it. I mean, if you think about it, Windows, you think about all your devices, your phones, the operating systems there that run phones and the applications that are run there, they're still, I won't say they're monolithic like, the old Windows applications used to be, Win32 and stuff, but they're not as modern as what the cloud capabilities are. And so we need those cloud developers to also work at the edge. And we need applications to be able to run the same application running in the cloud, running at the edge, on the same containerized architecture. For that to happen and be synonymous, that will drive the computer vision even faster.
Now, he's semi-retired, but he's far from done. Alec is diving into some exciting new ventures, including the world of computer vision.
And so we started working on adding computer vision to that before COVID, but it accelerated big time with COVID. And so loss prevention, the ability to recognize what that is. I mean, you recognize right away, banana, a scale's not going to recognize that, but a camera. So if you go into any grocery store now, you'll see cameras up there, and they're analyzing the fruit and what you're picking. There's all kinds of techniques people have when they're going to their self-checkouts.
We'll explore his journey at Intel, his thoughts on evolving technologies, and where he sees AI and edge computing headed next. Please make sure to follow us on LinkedIn and YouTube to stay up to date with most recent episodes and executive insights. Hello, everyone. Welcome to AI Insights, the Executive Brief. Today, I am with Alec Gefrides, and he has 27 years, or was 26 years with Intel Corp, and he was the VP of Network Edge Group. Now he's, I wanted to call it all the way retired, semi-retired, because you're also diving into some other exciting stuff with computer vision, which we'll get into here in a sec. But Alec, go ahead and do kind of a grander, more formal introduction here.
Well, Ben, I appreciate you having me here. So year out of Intel, and spent a lot of time the last 10 years at Intel looking at computer vision and what's happening with AI and the edge, primarily focused on the edge side of things, not so much the cloud. Lately, doing a little bit of consulting, coaching startups, just having a good time, enjoying a lot less stress than the corporate world, and trying to give back. It's partially why I do these types of things. I like making sure we get education out there. So,
yeah. Awesome. Well, thanks for joining me. I've been excited to have this conversation since we talked and kind of formally met about 2 or 3 weeks ago. And then we both had kind of some vacation plans. Mine was more vacation. You're coming back from Germany, but I'm so excited that we could finally get together and have this conversation. Now, one of the things I always like to ask, 26 years at one company is rare nowadays. You don't get that often. I was 13 years, and that was my longest tenure as an IT director for a printing company. But 26 years, that's a long tenure. So 2 questions I've got with this. First, what was your entry point into technology? How did you first become interested in technology? And then also, was this a consistent 26 years, or was there ever a time where you were I kind of want to bounce out somewhere else? Or was Intel so good that just that 26 years, it was just a fluid 26 years?
So it was a fluid 26 years. I've only worked for 2 companies. I worked right out of college for Siemens for 9 years, still in technology, and then 26 years Intel. The engineer, so definitely, all my toys as a kid got taken apart. So, diving into technology and how things worked was, part of the DNA. Couldn't help myself. With Intel, why did I stay 26 years? And it's a simple answer is there was just so much you could work on. I mean, I got to work on the first Chromebooks. I got to work on Google Glass. I got to work on Wi-Fi and putting Wi-Fi in planes. So there was plenty of things to change. And the nice thing was 3 or 4 years you work on something, and then something else interested, you could just go jump on the next topic. And if you ride that technology curve, as new things come along, then Intel was always there. And the other thing that kept me there was the access to the brightest and best companies. Was the account manager for Google for 5 years along the way. Ran groups, engineering teams. So just had a wide breadth. Worked abroad, got to see the world. So it was just, for me, it was a great place.
Yeah. No, so there's been so many technology or technological changes since, well, let's say 20 years, 10 years. And now with AI, it's advancing even faster. But it seems like you got to work on a bunch of different technologies, a bunch of what you would even call cutting edge and bleeding edge technologies over at Intel. Is there one specific technology that you kind of look back with more fondness where you're like, oh, it was just exciting. There was just this rush. And you kind of see that with AI where there's a lot of excitement, maybe too much excitement in some ways. But what kind of technology did you work on? Was it multiple, or is there one that really comes to mind?
I would say it's the trend or the pendulum of how computing works. That's what I really say is exciting. And what I'm talking about is we all started out with computing. If we look back when I was in college a million years ago, it was all mainframe, VAX. It was computing was centralized. Then we had the IBM PCs come out about midway through the 80s and really um, bring it down to what I would say local computing. And now those were isolated nodes. They were not connected. You add networking into there, and now all of a sudden you've got now a networked computing, and you had servers come in, and it started to shift a little bit, back and forth from edge to what I would say is centralized, is the term I would use.
Yeah.
Cloud came. Cloud changed everything in the sense that the edge could be, offload the edge. Cloud took us way far, far over to the centralized. We all use our phones now constantly, and the phones, they're intelligent. They have a lot of compute power today from what they are, but all the hard stuff, the applications are really running in the cloud,
Yeah.
and our phones are displays. Yeah, they have sensors in them. They have GPS antennas so that they can do things like navigation and a lot of great features that we use on our devices. But the cloud has really been the last, I'd say 15, 20 years. And right now, with AI, we're going to see that pendulum swing back. And that's really what's, my time at Intel is Intel plays in all places. It plays on the edge, plays in the cloud, plays in the servers, plays in networking. And so to be able to watch where the compute happened, that's what excites me. And what we'll talk about later today about computer vision, that's something that's driving all the compute to the edge.
Okay.
You can't push all that video up to the cloud. You need real-time decisions when you're using computer vision. And so that's something that's going to move the place where the computing happens. So I'd say that where computing happens is what's been my favorite thing with technology.
Yeah, that's an amazing perspective, and we'll definitely jump into that more. I do have another interesting question, and I think about I have 25 years in technology, so I started fairly young, and I think about all the times that I got trends wrong. And for example, I remember this not argument, but this discussion I was having with our maintenance guy, and we were talking about Google or Yahoo. And I was like, no, it's you Yahoo something, right? It was all about Yahoo at that time, and I was really stern on like Google will never replace Yahoo, right? I was wrong with that. I remember a conversation about BlackBerry and how no one would use the touchpad on a phone because it was just so inaccurate and you won't use that. So can you think through any technology advancements or trends where you got either right or wrong or like kind of the same kind of thing?
Well, I got Yahoo right to get out. So I was in, the dot-com era, I was definitely a trader. I wouldn't say an investor at the time. And I saw that it was a bubble. So I knew, I made a whole bunch of money. I think it was like 35 grand on Yahoo. got out and thought, where should I put my money? And I just looked up, and I was stupid at the time. I should have done, mutual funds or, ETFs. But I thought, one individual stock. Well, I looked up what was the most widely held stock. It was Lucent. So I dumped 35K into Lucent, thinking that was a good move. And that went to 4K before I finally just dumped it. It happened fast. I was like, this can't happen. They're the most widely held stock. Well, what is
Right.
going on? So, guessing on technology and investing is not one I would recommend. But I would say that was a painful one.
Yeah.
I did learn not to pick one stock only. But what are some things I've missed?
Did you see Google's success? Like, did you anticipate or even kind of, I never even saw, I mean, where Google is now compared to what Google was just a search engine, right? Back in the day, I wasn't even close that Google would
I
become
was
as
really
innovative as it
fortunate
was.
from '09 to 14. I was Intel's account manager for Google.
Oh,
And so I went through all of I got to see the very first versions of Android with Cupcake. I got the early versions of Google TV, all of those Google Glass, the self-driving cars. I mean, I got exposed to all of what they had going on. So no, I knew that one
mm,
pretty early. And Chromebooks, just inside Google, they had so many, if you would, competing operating systems. Um, they're not really, but in some way it's resources that are competing. So definitely, I saw that where Google was going to go.
interesting.
Um,
What about NVIDIA?
Definitely knew that they were a threat to Intel and were
Yeah.
kicking our ass. So yeah, I saw that coming. Their CUDA language, they're one that's similar to an Apple. They're all about their locked down platform. And where I've grown up is I'm a big fan of open source, big fan of open platforms, and
Yeah.
believe that that's the way that we drive the most compute and the most technology advancements. Uh, I love that all the AI work right now around the generative AI is being done a lot in the open, and
Yeah.
you just go through the GitHubs and look at all the applications and things being developed. It's fantastic. There's one I didn't call: Microsoft buying GitHub. That one
Oh,
made total sense after it happened, but man, I did not see that coming. I would have never thought Microsoft would have jumped on board with open source, and it's a brilliant move by them.
yeah. But
So
very counterproductive to how they usually, not productive, but counterintuitive to how they usually have gone to market and attack the market.
yes, absolutely. I mean, but now they get to see everything that's happening in the entire, call it, open source world, and see those trends. And I mean, I imagine they're searching through all of that and looking at and seeing where they need to develop their platform. So I think a
Yeah.
brilliant move. I mean, features for Azure, their cloud technology. I don't think they care that much for Windows anymore, but for their cloud capabilities, I do think that they're really doing a great job with adding the latest features, and having GitHub definitely helps there.
Yeah.
Um,
Interesting. Well, yeah, thanks for, I always like these little like small trips down memory lane. I think especially with technology and I mean, it advances, it does advance so fast. And now we're at a stage where this is, it's going to rapidly advance, I think, faster than what we've ever seen because of AI and what it's able to do and the ideation and creation behind it. But let's talk a little bit about computer vision. When did that first become of interest to you? When did you start seeing it? And now I know it's something that you're still interested in, you're still looking at, you're still participating in these discussions. But where did that start? Where did that curiosity start?
so I think, if you're a sci-fi geek or somebody that follows tech, giving robots sight or giving computers sight is something that has been around for a long time. So can't don't think anyone can claim that that's something. But adding cameras. Security cameras been deployed for a while. Those were all analog for the longest period of time. They were just recording on VCRs. They digitized that so it could be hard drives. You have 30 days of, my security system holds 30 days worth of data and then re-records. So it got cheaper. It wasn't VCR or tapes any longer when we moved to digitize. But once you digitize that, now you can start doing analyzing those digital streams and filtering out things or looking at things. And so that really started happening, I'd say 10 years ago is probably when we first started looking at it. What attracted me, so the segments that I was managing at Intel, one of them was retail. And retail, what accelerated it was COVID. We went and had we put up all the plastic plexiglass screens in front of all the cash registers right away. But it became very obvious that self-checkout was going to become, and it just accelerated the deployment of self-checkout. It was happening before that, but not everybody was forced to use it. All of our data and what we were looking at was people were using self-checkout were the younger generation. People that liked interacting with their phones were the same people that were going to go to the self-checkout line. But with COVID, everybody was forced to the self-checkout line. Well, what came with that was loss, theft, people stealing, and you call it accidental theft. People were taking, the simple ones were, 1 scoop of peanuts, 3 scoop of cashews, and saying that it's peanuts. Taking 2 bottles of wine and you scan the $5 bottle of wine and the $50 bottle of wine. The guy comes over to check your ID and he sees, okay, on the screen, 2 wines, good. They weigh the appropriate wine because you've got the scales there. But weren't realizing that they were selling that $5 bottle of wine twice, and that $50 bottle of wine was going out the door. Picking the less expensive bananas get sold like crazy. A typical store might have 200, or a grocery store might have 200 pounds of bananas, but they sell 400 pounds of bananas. And you go, how do they sell 400 pounds of bananas? Someone walks up, puts a pineapple on there, picks bananas. And that weighs the appropriate amount. And so we started working on adding computer vision to that before COVID, but it accelerated big time with COVID. And so loss prevention, the ability to recognize what that is. I mean, you recognize right away, banana, a scale's not going to recognize that, but a camera. So if you go in any grocery store now, you'll see cameras up there, and they're analyzing the fruit and what you're picking. There's all kinds of techniques people have when they're going to the self-checkouts. You take a Kool-Aid packet, you lick it, you put it over the barcode of your expensive item, and you have just the Kool-Aid barcode showing, and you scan that. So there's all kinds of ways
you can clue about all this. This is I don't have the devious mind to think of these ideas. That's insane.
Yeah, so loss prevention was one where I really dove into computer vision. But there's a lot more. I mean, it already started with the self-driving cars. And that compute for self-driving cars, that can't go to the cloud. That has to be done locally at the edge. So you're putting more compute. Those cash registers that are adding computer vision, that's done locally. That's not done in the cloud. And so the algorithms and learning, every time you add new products into a grocery store, you can teach and train models in the cloud. That's where most of the training is going to happen. But the inference, the ability to recognize the objects, that's going to be local. It's going to be local compute. And we're going to just see more and more applications. Another one we worked on is in another segment in manufacturing, welds on the assembly line from an automotive company. There's thousands of welds happening, and those are inspected by people for the longest time. And just putting a camera there, it can recognize if there's a mistake on that weld, and it's more accurate than people. The other one is textiles or fabric. Still today in offshore locations where these huge, textile machines are making huge amounts of fabric, and they have people that sit for 2 hours and just sit there and watch. And if the thread gets out, so that the pattern on your shirt or the thread gets messed up, when that happens, when a mistake happens, it keeps repeating itself. Okay, the weaving is getting messed up, and so it's ruining that whole section of fabric. Computer vision, computer can recognize, see a whole machine, and immediately say, "Oh, we got a mistake. Let's fix that." So there's so many places you could start with that are just super easy. They're not all about robots taking over the world with computer vision, the ability
Sure.
to recognize.
So do you think there's a place in computer vision where you could call it being stuck, or do you think where's the biggest room for growth or advancement in computer vision? I think in any technology, you always, and even in AI, you get stuck and then you break through that hurdle, right? And then you get stuck and you break through that hurdle. I think one example is like the cloud, and advancement with the cloud was really limited because of connectivity, right? Like T1s, even bonded, they weren't supporting the use cases, especially when you talk about voice in the cloud and VoIP and things like that. Is there something similar with computer vision right now where there's a idea being stuck, or this next big idea to advance computer vision to the next level?
So I'm going to give my opinion, but there's going to be a lot of differing opinions on this. The computer vision and building the algorithms to do that, license plate recognition for one, that's around. Bone breaks on x-rays. I mean, there's so many things you can do that you can analyze with computer vision. The challenging part is building those algorithms and training to build the training that goes on to recognize a cat in a video or recognize a bone break. That's all done in the cloud. The cloud is a very microservice driven. It's all containerized. You add the compute there. Well, the edge is still somewhat monolithic. It's not built on the same architecture as the cloud. It is moving that way, but that's probably the biggest hindrance, in my opinion, is we need the edge computing to be a microservice, container-driven architecture similar to the cloud. And for that to happen, you really need the people that have developed the cloud to start working on edge devices. The edge people are coming at it. I mean, if you think about it, Windows, you think about all your devices, your phones, the operating systems there that run phones and the applications that are run there, they're still, I won't say they're monolithic like, the old Windows applications used to be, Win32 and stuff, but they're not as modern as what the cloud capabilities are. And so we need those cloud developers to also work at the edge. And we need applications to be able to run the same application running in the cloud, running at the edge on the same containerized architecture. For that to happen and be synonymous, that will drive the computer vision even faster. And so what will happen is then you can do training in both places. Okay, simple example. Coca-Cola, they have their Christmas Coke with the bears, the polar bears on them, or, you got your different packaging. So when you're recognizing, computer vision is not just picking up on the barcode. The computer vision is picking up on the packaging, the sizing, all kinds of things. And so you have to, the future is going to be, you're going to deliver when you have a product and you want to go into Walmart or Target or Safeway, it doesn't matter. You're going to deliver digital images of your product. Okay. But when Christmas season comes, you got the Halloween mac and cheese package, or that is adding now a new item into your system. And that should be able to happen just by scanning it. It shouldn't be that you have to go and retrain your model, add all your new products for that, and then download those new models to all your cash registers. that's too cumbersome. That should be training done locally. And that's where the architectures have to be similar. Compute architecture is what I'm talking about. So it's those types of things that I think slow down. I mean, right now, all you hear about is generative AI. We're talking about really asking questions and getting human-like responses back. And that's where the focus is on artificial intelligence. But you add that plus giving computers sight, wow, there's a lot of power there.
Yeah. So and now I'm thinking, security. And when I think of cybersecurity, the cloud has always been inherently easier to control in some ways because I think it's more centralized. And you start talk about bringing this all to the edge. I feel like there's going to be some security concerns that also have to be solved as we start bringing everything back to the edge. Or do you feel like where do you fall with that? Does that make sense?
Great question. I mean, very important. I just joined a board of a startup called Bike Trail out of Dallas that's working on IoT security.
Yeah.
The key thing is it's got to be, you've got to keep all those endpoints up to date. So it's not that the devices are insecure if they have their latest patches. The problem is people don't keep them up to date. Okay. PCs, phones, they're pretty good at patching. That happens. That we're all doing. Cameras, all the devices at the edge, nobody thinks about securing those. And that is a problem. And I don't know if you remember, there was a few years back, Spectre and Meltdown was a huge security threat. It was Microsoft, Intel, the Linux community, AMD, and we all had to work together to go solve that because it was multiple places of entry point or security breach. And the biggest thing we found, we all could create the patches, and with Windows, it was easy to deploy those patches. But when we were looking at those IoT devices, those Linux kernels hadn't been updated for 3 or 4 generations. So the kernel, if it's not updated, you can't apply the latest patch.
Yep.
And so that is something that is difficult with the IoT devices, that they're not keeping them up to date with their software. And it's not just the patches, it's the kernels. They have to catch the whole platform up to date. And so this is a real problem. It's a problem that's not solved. That's why I got involved with a startup to look into this, because I do see this as a gap or something that will slow down. I mean, I feel like the PC space, the phone space, we're pretty good at patching and securing and keeping them locked down. There's always going to be new breaches or denial of service attacks, but we're adding sensors and cameras and all kinds of stuff at the edge that hasn't been there before. As we digitize the world, turn everything from analog to digital, security will play a big role.
Yeah, IoT devices have always been inherently more difficult to secure, than your typical endpoints. I think, and I don't quote me on this, but it was Target or one of the major breaches happened through a thermostat. And it may not have been Target, but they actually breached it through a vulnerability in their thermostat.
Yeah.
And so, and there are, Tenable has there are companies that do decent IoT security, but this patch management, mobile device management, and this, it's going to become more prevalent, as you're saying. So this is fascinating. Question about Intel with AI. I was just thinking about this. Intel obviously always innovative, always keeping, ahead of cutting edge, bleeding edge. Was AI just something that they saw being this big throughout your time there? Or was it something there's been AI forever? Intel is working on machine learning, deep learning, all this stuff for a while, but did they see the trend to this kind of commercialization of AI while you were there? Or do you think people were caught off guard by it?
No, definitely saw it. I think what it is, and everybody has their own method or architecture. Intel's x86, and right now, I'm a year retired out of Intel, so I probably can't speak for Intel any longer. Is what I would have to say. But Intel has their architecture. NVIDIA has, worked in GPUs. GPUs happen to be very good at processing certain workloads. The CPUs that Intel creates are very good for generic workloads, or broader number of workloads. And AI, where AI is today, especially both computer vision and generative AI, those focused graphics processing units are really good at processing that. So their architecture, a little bit of luck there, their architecture was more in tune with what AI needed. So it put them at a higher space. Now, Intel has GPUs, Intel has general CPUs. And as we go forward, there's going to be different, flavors and different things that are going to need. Most of my conversations with customers would go, all right, I built this out on NVIDIA. It works. It can do everything I need, but it's $10,000 a node. It costs me too much, and I'm locked into their software, so I can't leave. I mean, it's a good model. I have to admire NVIDIA for what they've done.
Sure.
For Intel, we get the phone call of, hey, Intel, can you help us cost reduce this and get this down to 1,000? And a lot of times you can. A lot of the workloads don't need the NVIDIA performance. And so we have to create translators to help move their software that they've all created to a different architecture. So it's really an architecture battle that happens out there. I wouldn't say that Intel was, missed it. I would just say that didn't have the right technology for what came along. And that's a lot. That's a luck at times. There was times that you have the right stuff. I think, examples, you can go back. Intel got super lucky that the architecture from desktop PCs to mobile PCs and the wireless of Centrino, same thing happened again with cloud, same thing happened again with telco. So there was a number of times where Intel got it right. The AI one, that one, I wouldn't say we got it wrong, but the architecture that's of choice right now is the GPU.
Sure. And I mean, Intel, they pivot quickly. And now you were talking earlier, I thought there was something, was it with computer vision, something that Intel has in regards to computer vision or AI? Or did I misunderstand?
Oh, no. There's definitely tools and things that everybody's creating. The one that we and I talked about was Intel's Getty platform, which is it's fun for if you're trying to get into computer vision. It is a simple way you put a camera up, put a camera stream in, you bring it into the software. And let's say that you're filming a warehouse, okay? It's one of your security cameras, it's in a warehouse. And let's say you got forklifts running up and down that warehouse. And you want to be careful with people walking through there. So you've got safety lines. Maybe you either put them on the floor or you can put them actually only on the video. And then you can, have somebody that's walking by. And if somebody walks by with a hard helmet or a hard hat and a safety vest, and you circle those two things on the software platform and say, hey, if they go into this section, I want to have a warning come up. And so really easy way to annotate and be able to add computer vision to an everyday experience. So now you annotate that if any person walks in here without a hard hat or safety vest, we're going to send out a signal. Now we can have red lights go on or whatever you want to do to control your situation. All the forklifts automatically stop or all the robots stop if you're in an Amazon warehouse, whatever you're doing. But makes it really simple to say, all right, I'm going to throw up some cameras. I can go annotate and say, got to have a hard hat on to be in this section of the camera's purview. So there's fun software out there to be able to go do that. And so I had just mentioned in one of our conversations that Intel Getty is really cool that you can play around with it. And that's just a simple example.
Yeah. Very, very cool. So now I want to talk a little bit about governance and just putting guardrails on. It seems like AI is moving so fast and there aren't a lot of guardrails. I also see it as being very difficult, especially when you're getting into the image manipulation, video manipulation, deep fakes, things like that. I mean, I have my AI avatar that I introduce my episodes with. That's, of course, with my consent. It's kind of cool, but it is scarily accurate to myself and saying, is that me? Is it not? And I think as technology advances, these are going to be even more difficult to control. But where do you see us going forward with guardrails and, again, governance and putting some kind of system in place that protects us against improper AI usage? Because we're seeing it already, but it's going to become more prevalent, right?
Yeah, I'm definitely going to get this wrong. I'm definitely, because it's, I mean, privacy is a huge problem, and stealing identities. If we think about, likeness and, just the college athletes now with, the likeness and what they're
Yeah.
getting paid for. So it has to happen, but I don't know how.
Yeah.
And some level you want to be able to innovate. I mean, I've seen cartoons that people have created with all the, if you remember the claymation or the ones that were made by, I think it was Rudolph the Red-Nosed Reindeer, all
Yeah.
those things. They, they've got, you can go out and see Simpson episodes that are using the characters from old Rudolph, and you can see all kinds of stuff that people have regenerated stuff,
Sure.
which intellectual property is, I do not believe we can lose the protection of intellectual property. That has to be done. And that's from patents, that's brands. I mean, intellectual property is important. Secret formulas like Coca-Cola. I mean, these are things that must be protected. And in
Yeah.
some countries, they aren't. And in some countries, they're very liberal there. And it's going to get more and more difficult.
But
Um,
wouldn't you say too? I mean, you have to see the misuse sometimes to understand what you're even protecting against. I'm going back to that conversation you're having about how people were basically stealing groceries. If you didn't know that someone was licking a Kool-Aid packet and putting it onto something, you wouldn't know that that's something you even needed to protect against, right?
right.
And you go throughout time. I mean, and I like with my psychology roots and my studies in psychology, and you look at the first psychology studies that were done that were horribly unethical, but you wouldn't have known to put guardrails on there because you didn't know people would do that kind of horrible atrocity, right?
Yeah.
And I don't, hopefully, I mean, there might be some atrocities with AI or perceived, but maybe it's the same thing, right? Like, unfortunately, we're going to have to open up the innovation. People are going to then show us how it's misused, and then we're going to have to put the guardrails. Does that kind
For
of make
sure.
sense?
No, that's for sure. I mean, there's things you can imagine already, and you have to start. I don't know how you can write all the laws, and policing those laws is going to be the problem. I don't think it's going to be
Yeah.
hard to write laws. I don't think it's going to be hard to come up with what's not appropriate or not allowed. What's hard is police. How do you stop it? How do you infringe? How do you catch? That's the hard thing.
Yeah. Interesting. Hypothetical question. I always like asking all my guests this. It goes around Elon Musk Neuralink. If you could put a chip in your brain and speak every language, have unlimited knowledge in your brain, it might go that way. I know that's kind of sci-fi, but who knows? Is that something you would do? Would that be tempting to have unlimited power in your brain if it was safe and all that?
Well, I think back to the Matrix. If you can download, a new fighting technique or a new, language or something, if you can just download that to me, absolutely, that would be awesome. Having just spent my entire summer in Europe and the last 2 weeks, some of the countries I was in, Germany, I can speak the language. I feel really at home. But I spent 2, 3 weeks in the French Riviera, had a flat tire, disaster. Couldn't talk to the auto mechanic, couldn't talk to the tow truck driver. Rental cars do not have spare tires anymore, which is just beyond me.
Right.
So I don't know if Tesla set that in motion or who, but no
That is
rental cars
weird.
have.
I had that issue in Sydney this year too. I got a flat tire in Sydney, and I'm like, "Where's the nope?"
You have to call a tow truck for a flat tire. It's ridiculous. So the Google Translate helped me tremendously.
Okay.
I mean, it did get me through dealing with tow truck drivers, but you can't use it on the phone. So calling the help dispatchers and all that, you know, I tried saying something and then hit the play and have my phone. I was like, okay, this isn't working. So I'd have to say it into my wife's phone because he couldn't hear it when it was playing on my phone. So I'd have to say it to my wife's phone and then play her phone into my phone. I felt like I was a disaster. I mean,
Oh boy, that's funny. That's an adventure.
So putting at least in Sydney, you were speaking the same language.
Yeah, true. Yeah, mostly, right?
I mean, would I go? I wouldn't be first. Let's put it that way. Usually, I'm somebody that wants to be on the leading edge. I mean, I've got a pair of Google glasses from, the first month they were out. I love that kind of stuff. Being on the first, probably wouldn't be on the first million on Neuralink.
Right. I go back to the security thing. I mean, again, if it was perfectly safe, it's proven and all that. But obviously, if you have that in your head, you could be hacked, and having someone be able to hack my brain, which we're being hacked constantly with social media, right? I mean, it's kind of funny. We're definitely, our brains are being hacked every day with subliminal messaging and everything from social media. But my big thing is suddenly like a Beetlejuice moment where we just start dancing out of the blue or something. But no, it's an interesting thought. I've also thought of it being like bodybuilders who, like, when you think about the risk, is people who are really into fitness and in an unsafe way, who are taking steroids and all these unhealthy supplements. They're willing to risk the adverse effects on their body to be able to gain a competitive edge in bodybuilding. And I'm sure it'd be the same thing with this, right? There are a group of people that, hey, I'm willing to risk the adverse effects. It's a funny, what would you call it? Not psychological, but
a thought experiment. It's a good thought experiment.
Yeah, exactly. Kind of fun. All right, Alec, this has been great. I really had a lot of fun with this, and I've learned a ton too, which I really appreciate. Last thoughts, anything you want to leave with? Last thoughts on computer vision, AI, technology. It's yours for last thoughts.
I love it. I keep playing in it. So I'd like for the community that we're there, we all have to be responsible. We all have to think about the good and not necessarily what we can do, the fraudulent things. We're going to have mischievous people out there, and we have to protect around that. So I'm going to spend time on the security side. Like I said, I joined a board of a startup to get there. And it's definitely something that's going to continue to happen, that we all have to be diligent and pay attention. Where I mostly worry, my final thoughts are the elderly. Having elderly parents, the amount of fraud that comes to them and me having to intercept it is just scary. And so one of these days, I'm going to fall in that bucket too, and hopefully my kids are there to filter and block everything for me.
Yeah, that's a good point. There's already a huge problem there and a huge risk with these deep fakes. But Alec, thank you so much. Really, I appreciate you just taking the time. I know you've been traveling, you just get back, and I just appreciate you sitting down with me, and your insights were just so valuable. Again, thank you so much.
You bet. It was fun. Thank you.